So we're going to move into right triangles. Okay? When we go to right triangles, you use what formula? Remember? Pythagorean theorem. Okay? Now you know what formula is? Right. So when you use this formula, what was the last step? Remember? You square root it, right? Because you get like, I don't know, some number, let's just say 15 equals c squared, doing all these steps, and then to get c by itself, you have to square root that, c square root that, c equals that's up there, right? Well, now you're going to have to be able to leave it in simplified radical form. Okay, so that's the only difference between what you did now and what you did now. Okay? Alright, so what is a radical? All a radical is that it's a square root. Just another name for it. Okay, y'all probably called it square root, right? Okay, it looks like this. You'll hear me say radical, okay? Because that's one word for roots. Radicand. Radicand is the part, okay, or terms under the radical. Okay, so it's the terms that are under the radical. So you're going to see that, and you might have 24x squared. Well, 24x squared is what you call the radicand. Okay? So all of that is the radicand. So if you hear me say radicand, you know what I'm talking about. Okay? Right, Hunter? Coefficient. You should know what a coefficient is. It's just a number, okay, or a term that is in front of a variable. Well, in this case, it's going to be in front of the radical. Okay? So the term front of radical. So you got something like 3xy radical 24x squared. The part that is going to be the coefficient is that part right there. Okay? 3xy. That's one term. Okay? It's the number and it has variables. Okay, so know what I'm talking about when I say radical, radicand, or coefficient. Okay? Alright. When we are simplifying radicals, it's good to have the perfect squares kind of in our head. Okay? So like a perfect square would be like 1, because the square root of 1 of that is a whole number, that's just 1. The next perfect square is a 4, because the square root of 4 is 2. Okay, it's a perfect whole number. The next perfect square is 9, because the square root of 9 is 3. Okay, so take the square root of 9. So they come out perfect, like a perfect whole number. Not like that 15. Maybe take the square root of 15. That's like some decimal. That's not a perfect square. Okay, so 1, 4, 9. What's the next one? 10. Are you got it? 196. 1, 2, 56. 2, 9. Maybe higher than 33. Oh, it's not a 225. What? Okay, so obviously we won't have like those memorized, but like at least get up to 1.5. 44. Those are all the ones that stop like a little bit after that. Okay? So just, good to keep in mind because, all of these square roots again come out as a nice vertical number. Okay? And I'll tell you why. Okay, a real easy way, okay, real easy way to simplify this is, again, if you were to put that, if you were to put physically calculator, you're going to get some decimal, okay? Can't leave it like that, okay? So from now on, put the radical in there, you get a decimal, on count either half wrong or all of it wrong because you got to simplify it. So here's how you simplify. You just use a factor tree. Okay, this is the easy way. So what are your multiples for 32? Pick two numbers. 8 and 4. Good. 8 times 4 is that. Okay, and then you want to keep going all the way down until you can't go or till you get to prime numbers. Okay, so what is this? 2 and 4. 2 and 2. 2 and 2. And that's it, right? 2 are prime numbers. Okay, so then once you get to that, the next step it says, just take pair up all the numbers that you see there at the bottom, that is, but ignore the 4, the 8, and the 4 now. Okay, just the 2s. So let's circle this pair, and then circle this pair, and then that one is all by its lonesome, so you want to underline that. Okay. So then what you do is, with the paired numbers, you're going to pull them out, and they're going to become a coefficient. So a 2 will come out, that 2 will come out, and then anything that's underlined at the end, you're going to put it back under the radical as a right hand. Okay? Yeah. And so then this right here, you don't want to leave it as 2 times 2, you just make that a 4. So 4 radical 2 is a simplified radical for that. Okay? And so you're going to use more of this when you get into algebra 2. Anybody taking algebra 2 right now with geometry? Okay, so you're going to use more of these next year. Yeah.
So 1 pair equals.
Right, good. So like this is a pair of 2s, so you just take that 2 and put it there. Not both of them. Okay? So basically, whatever you circle, just take that number and got it. Okay? Yeah. If there's more numbers, then you just multiply them like we did. Let's say we underline a 3 somewhere over here. Well, the 2 and the 3 go under the radical. And so you don't write 2, 3, you write 5, 6. You always multiply everything. Okay, we're going to do some examples that happens. Okay, now this one out here, this one right here is using perfect squares, okay? It's not harder, but you got to put a little bit more thought into it. Okay, and we'll practice as we do the example. But what you want to try and do is you want to try to pick the greatest perfect square possible. Okay? And when you can do that, you'll just have a smaller tree and be done with it quicker. That's the only advantage here. Okay? Other than that, if you want to just stick to the easy way, just do it this way. Okay? But what is you want to do with the greatest perfect square that goes into that evenly? No, the greatest perfect square. So you get it off that list. 16 times 2. 16 times 2. Which one is the greatest perfect square then? That's 16, right? What is the square for 16? 4, okay? So think about it. 4 and 4, right? You can stop right there and circle that pair. And that can happen in any case. So I don't know if you notice up here, we had a 4 times 2 and a 4. You could have technically stopped there and circled the pair of 4s. Okay? So it's just something you'll pick up along the way. If not, you can go all the way down so you can't go anymore. That's a pair of 4s. This is underlined. Look at that tree compared to this tree. See how you're already done? So where does the 4 go? Outside, radical 2. Okay, so see how it's the same answer? So this one up here, you're just putting a little bit more thought to it and trying to use a perfect square. and therefore your tree is going to be smaller. Okay? This one here is a real easy concept. You just factor it all the way out. You can't go anymore. So small pairs. Yes.
What do you do if there's not a third number?
What do you do? What?
There's not a third number or a number like itself.
You can underline the number?
Yeah.
That one? Okay, so if you don't end up underlining anything, are you going to have a radical? No. It's just like if you have a perfect square, which we're having an example of that. All right, that's it. So you can go back and look at these notes if you forget how to do that. Okay? All right, let's do one more example. Let's say there's a one with a coefficient. Okay? Only difference is you do the same thing that we just did, and then you just deal with that at the end. Okay, so let's do the tree. Okay, if you think of a highest perfect square that goes into that, what is it? 9, right? 9 is the highest perfect square. Okay, what's the square root of 9? Yeah, 3. So see, there's your pair. Now with 6, okay, think about it. Can you fix our multiples? Is it going to give us any pairs though? No. So you don't have to. You see that? Like 6, I think another one is another one. 10 is another one, which is 5 and 2. Right? Then you can you don't even have to bother writing those out. You're going to just send it over back anyway. Okay? So then underline the 6. Okay, so then what you want to do now is where's this 3 going to go? Outside. Okay? So it's going with that 5. What are you guys going to do when they're together? Multiply. So your answer is going to be 15 radical left. So that's the simplified answer for that right there. Okay? All right, let's do some examples here. 18. Which one's better to do, 6 or 3? 6 or 19? That one's only if you want a smaller tree, but 6 and 3, you still get the same answer, okay? But 9 is a perfect square, so then you'll have a pair right away. And then that is underline. I like to say underline because it's kind of like a reminder to go under the radical. So that's just a strategy that I use to help you guys remember. So then what do we get? Okay, next one. What do we get there? It's prime. Good. So anytime you see a prime number, you're not ever going to get any pairs. So that's as simple as it's going to get. That's the simplified answer. Okay? What about this one? Yeah, right there, looking at that, you kind of have an idea, some of those perfect squares, we just wrote it out. It's just 13. So see, do we have any underlying things in? So that you don't have a radical. All right, this one's a coefficient. Okay, we'll deal with that at the end. Let's do the tree. Give me a good pair of numbers. That's the good one right there. Why is that a good one? 100 is a perfect square. So you're going to have a lot smaller tree. That's the greatest perfect square. And see, you're done with that right here. Let me just show you real quick what the 30 and 10 would look like. 30 times 10, 15 and 2, 2 and 5, 3 and 5, right? All right, so that's it. So then you have a pair of 2s, pair of 5s, so the tree is bigger compared to that one, but you still get the same answer, right? So it doesn't matter how you do it, as long as you get the right answer. Okay, so where does the 10 go? Next to that. So how do we write our answer? Negative 40. You'll get the same thing over there if you use this 30. Alright, what about 192? Anybody know that perfect square? That goes into that evenly? That's very good.
64.
64 does, right? How many times does 64 go into it? 3 times, yeah. Didn't get that, so we had a big tree. that 64 is what? 8 and 8. So there's your pair, you can stop right there. Underline the 3. Okay. If I were you, I would remember that you still got that negative out there. Okay? A lot of people forget that negative. What kind of numbers out there? A -1. So if it helps, go right in the 1, just so you know that you gotta multiply the 8 out there with that -1. So what's our answer? Right? And then the last one, which numbers? Yeah, that's good because 25 is a perfect square, right? Okay, what's the answer? 65. How do you 65? Very good. Because that 5 gotta go out between it. And then we're gonna go what? All right. Good. Good. Okay. So pretty easy, right? Okay. Now the only difference on part 2, we're gonna add variables. Okay. So that's probably something that you didn't use either in middle school. When you might use variables here. Okay. All right. Same thing that you're going to do with the 72 that you just did. So give me 2 numbers. 8 and 9. Okay. What's that? 2. Okay. So what number technically is going to go out in front? The 6, okay, the 2, and the 3. The 2 of that. Alright, so we'll look at that in a second. Now, here's what you do with the variables. What you do with the variables is you expand them. And then you still stick to the little circle up here. So what's g to the 4th expanded? Very good. 4 p's. 1, 2, 3, 4. Okay? And then how many pairs do you have? 2. So all of the g's are going to come out. Okay? And I should say all of the g's. How many g's? 2 g's. Okay? And then the h, we've got to the 3rd power. It's only 1 pair, and then let's underline again what's going to go back underneath. Okay? All right, so now so 6 is going to go out. 2 g's. What's GG? Very good. G squared. And then h. Then comes a radical. What everything has underlined? 2 and 8. So that's your answer right there. Okay, now let me show you another way to work with the exponents. A radical is the same thing as doing this. 72 g to the 4th, h to the 3rd. This is the same thing as writing a radical. Did y'all know that? A radical is the same thing as having an exponent to the 1/2. Did y'all know that? No? Okay, well that's what it is. Well, in Algebra 1, your teacher taught you what you do to an exponent raised to another exponent. What do you do with those two? Do you remember that property? Very good. You multiply them, right? What's 4 times a half? 2. You see how we ended up having a 2 on there? Now, with the odd ones, it's different. What's 3 times a half? 1.5. Well, 1 will come out, and if you ever have a half, that one goes back underneath. Okay? So we'll work with doing the half. I'll show you. Alright. 36? Perfect square, right? Sometimes you don't even have to write the little 2, 6, and 6. Okay, so what do we do with the variables? You write them out. And then what is that? So it's just 6 in. We don't have anything underlined. Okay? Let's have the 2, y'all. 1. You see how that's into the 1? Okay? So let's keep talking about how fast what's happening. Okay, 45. 9 and 5, which makes it 3 and 3. Underline the 5. A to the 4th. 1, 2, 3, 4. So 2 pairs, right, of the A's. The only thing that's underlined is the 5. So what's my answer? What is 2, 2 with 1, pair, underline the 3 and the 5, right? Okay, B to the 7, B to the 7. 1, 2, 3, 4, 5, 6, 7. 1 pair, 2 pairs, 3 pairs, 1 left over. Okay, so let's go back and do what's a half. What's half of 7, yo? 3 and a half. So see how 3 are going to come out, and then that one, remember the 0.5 that's in here, that leftover stays in the variable. All right, how do you get your final answer? Don't forget about this guy. Negative what? Negative 2 goes first. Remember, numbers always go first. A, B to the third. Remember, because half of 7 is 3 and a half. Radical 15 B. A little bit longer answer, but if you write everything out, you're right. Okay, let's do one more of these. Which one do you want to do? One on the right. Okay. Give me 2 numbers from the 92. 31 times 2. Huh? What? 46 and 2? Is that right? And then, what is that? 2 times 23. 23 is prime, right? Okay, so where's our pair right there? Underline the 23. What's half of 7 again? 3 and a half. So x to the third is going to come out, and then you'll have 1x underlined, right? You can't do the half. Remember, I'll try to tell you how to do the half. If not, do this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3 pairs, underline. See how x to the 3 comes out? 3 of them. Alright, and then the y, that's just one y, so I would keep that underlined. Okay? Alright. What's going to be out in the front? Negative 2. Alright. So that comes out. Then what? X to the what? Beta. Very good. That's the problem you should have remembered last year. X to the 3 is joining x to the 2. That means like they're being multiplied, right? So when you multiply those and they have the same base, what do you do to the exponents? You add them. So x to the third is correct. Y to the third, because there's no other y's coming out and joining that coefficient. And then what's left? 23 x y. Don't forget the y underneath that. And there it is. A little bit long answer, but so yeah. These are numbers of algebra 1 properties. Okay?